Hello, I'm making a game engine called Vox. This video is the first in what will hopefully be a long series of frequent, small updates on my progress. Currently, the engine is undergoing its first major rewrite, so things are a bit messy. If you're a C++ programmer, I recommend you watch the bit about modules at the end, which might help you avoid your own rewrite. Anyways, here's the progress as of now. It may not look like much, but a lot of preliminary work has gone into getting to this point. I'm doing everything from scratch without using any libraries. This is mostly because I want to keep a high level of control over every part of the engine to make sure that everything works well together, but it's also partly due to the fact that working with libraries in C++ is a huge pain, and most of the time they aren't even that hard to recreate. I'm also making this exclusively for Windows. This is simply because I've never used Linux or Mac before, and have no idea what goes into making an app for those platforms. Hardly anyone uses Mac, and for Linux, well, you can probably just use Proton and run the Windows version. I'll have to test that later to make sure I don't accidentally break anything, but it should be pretty straightforward. So why am I making an engine in the first place? Really, it's just because it's what I enjoy doing. I don't think it's a very practical decision, but hopefully it'll pay off someday. I have a few ideas for games I want to make with this engine, one being a 3D boomer shooter with a pen-drawn style, another is a multiplayer mining game with PS1 graphics, and another is a 2D pixel art puzzle platformer. So I'll try to make the engine as versatile as possible so that I can work with whatever type of game I want. But to be honest, I'll probably do the 2D one first since that's the lowest scope. A lot of the work done on this engine is hiding in the foundational layer that just makes things work. Let's start with the asset loading system. The engine splits assets into two foundational categories, each stored in its own folder and separated by type. So there are folders for sounds, textures, models, and each other type of asset. The first fundamental category is source assets. These are the editable or exportable file types. For textures, the engine uses PNGs, which I wrote a PNG loader to handle. For models, it's either GLB files or Blender files. These files don't actually represent the file used by the engine. Instead, you use VX files, which are just JSON text files that store which source file is used and various other settings. I use JSON not because I'm particularly fond of it, but because GLB uses JSON anyways, so I had to write a parser for that, and decided I might as well reuse it. I'd eventually like to have a UI to edit these VX files, similar to Unity's asset settings, but I'm just not at that stage yet. Source assets need to be converted to compiled assets, which are custom binary formats designed to be quick to parse and load. To compile source assets, you just start the game with the -C launch option, and it'll automatically recompile everything. You can specify custom folder names if you want to, and again I'd like to have a UI for this, but it isn't needed just yet. The engine can recompile and reload assets while it's running, which should help with iteration speed. Right now, assets are always loaded and never unloaded. I doubt I'd ever make a big enough game that this becomes a problem, and if I do, it shouldn't be too hard to change. This method also has the benefit of preventing stuttering that most other engines suffer from. I'll quickly touch on the entity system before moving on to the graphics. Entities are object-oriented, which is a little uncommon nowadays. Most new engines use modular component-based systems, but to be honest, I've never really found that these kinds of systems are actually very useful in my past games. Most of the entities that I create behave so differently from each other that considering them to just be different things makes the most sense. Still, there's a little bit of a component architecture built into the engine. Components are built into classes themselves as fields rather than being added to an array like in Unity. Hopefully this gives the best of both worlds. When you create an entity, you don't get a pointer to its memory address like is common in C++. Instead, you're given a versioned handle to the entity. With a pointer, if you were to delete the entity then try to access it, there would be no way of checking if that entity actually exists. The memory address it was in could be reused by some other data, and your code might interpret that data as an entity, causing God knows what to happen. Versioned handles are entirely unique per entity. Even if the same memory is reused, you can check the version counter and see if the entity actually exists or not. This should make it a lot easier to prevent those use after free bugs. Okay, graphics. This engine is built on DirectX 12, which can be pretty difficult to use, but it offers a lot of very nice modern features. One of these is bindless rendering. The normal method is to bind which textures to use, material parameters, and which model to draw before you draw it. This can introduce a lot of driver overhead and hurt performance. Bindless rendering removes that overhead at the expense of some added complexity. But since everything is just loaded once, bindless rendering is actually pretty simple. I had to write a math library for vectors, matrices, and quaternions so that I could get perspective and physics working. It was a few days of confusion, but once it was done, I can be confident that everything is correct and in the right coordinate spaces. Most recently, I was working on window docking for the editor and in-game overlays. I got some UI rendering and experimented with rounded rectangles, but decided against it since it makes clipping stuff more complicated than it needed to be. After a couple days of working on it, I wanted to rewrite it to be simpler and more extendable for stuff like highlighting when you hover over stuff. I mentioned earlier that the engine was undergoing a major rewrite. Well, this isn't it. As I was in the middle of rewriting the UI system, I got annoyed by how long it was taking to compile. Over 30 seconds for some changes, which adds up. Up to this point, I had been using modules, a relatively new feature of C++. They supposedly improve compile times and come with some other features, but I didn't really know how to use them, so I decided to test as many variations of the asset loading system as I could. Combining many small modules into one big one with a lot of partitions may have reduced compile times by a tiny bit, but the inconsistency in results was bigger than the speed increase. It was a similar story by reducing those many partitions into just one big module, but a little more noticeable of a speed increase. I'm developing on a hard drive, so this makes sense since it should theoretically produce less intermediary files, but when I switched to classic header files, my compilation times were just cut in half, and sometimes even a third. This made no sense. How could modules be slower when they're binary and headers are text? Well, it turns out it was because of multi-threading. I don't know if it's because my project required Windows headers or if it's just a limitation of Visual Studio, but module compilation was running almost entirely single-threaded, and header compilation could run in parallel. So even if each individual file was taking longer to compile, it could compile multiple of them at the same time. Even then, keeping the size of header files in check was enough to make even single-threaded build times with headers roughly the same as modules. It's important to note that I'm using pre-compiled headers, which do reduce the compilation times massively. Modules do have some useful features. Being able to choose what you export makes the codebase very clean, and modules can be massive while still being very fast to compile, unlike headers. But the increased compilation times just weren't worth it. There are also some minor bugs that had been getting on my nerves for a while. Specifically, unexported symbols from another module partition aren't recognized by IntelliSense, even though you're allowed to do that. This would give you a bunch of red squiggles all over your code even if it compiles perfectly fine. You can get around this by separating all the stuff that's supposed to be hidden into another module partition, but at that point, you can kind of just use headers. Even worse was that IntelliSense doesn't recognize documentation comments or even function parameter names from modules. This wasn't that much of an issue for me since I already knew what everything did, but it would be terrible if I ever wanted to open source it or bring anyone else onto the project. Theoretically, these could be fixed in a later update of Visual Studio, but I wouldn't hold my breath. Okay, so what's next? Right now, I'm rewriting everything to use header files instead of modules. This will probably take a couple of days at least, but then after that, it's finishing the UI rewrite, and then onto text rendering. Hopefully, I'll have enough to make another update video sometime next week, but I'll probably be in the middle of getting text rendering working, and don't be surprised if it takes a bit longer than that. See you then.